So hello everyone, good morning. Good morning. So this is lecture number 4 of vector analysis. So I think my voice is audible. Yes, okay. So this is lecture number 4 of vector analysis. So if you haven't watched the previous 3 classes, go through that. So in the last 3 classes, we have been discussing about gradient, level surfaces, tangent, and normal to the level surfaces. And then in the previous class, we have did some problems based on angle between the two surfaces and so on, right? Okay. So in this class, we are going to introduce what is meant by divergence and curl, right? Divergence and curl. So we are in first subtopic. Under vector analysis, which is gradient, divergence, and curl. So we will start. What we're going to do in this classes, we are going to define 4 new things: the definition of divergence, the definition of solenoidal vector, the definition of curl, the definition of irrotational. So we're going to see 4 definitions, and we're going to do some problems based on those 4 definitions, right? This is what we're going to do. So we're going to introduce 4 new definitions now. So we will define what is meant by divergence now, right? Okay. So we will define divergence of a vector point function. So for we will define a gradient for scalar point function. Now we're going to define divergence for a vector point function, right? Okay. So definition: divergence of a vector point function. That is, if you give some input, the output will be a vector, right? The divergence of a vector point function. So we will define this. So let capital B be any given differentiable vector point function, right? Let capital B be any given differentiable vector point function. That is, let us take B to be equal to some f1 I vector plus f2 j vector into plus f3 k vector. Remember, this is a vector point function. So that means the output will be a vector. So here, what is f1, f2, f3? f1, f2, f3. F1, f2, f3 are some function of x, y, z, right? Where f1, f2, f3 are functions of x, y, z, right? This is the vector point function, right? For example, if you apply gradient to scalar point function, the output will be a vector point function. You just go to the previous problems, you just look at the answer for gradient, you'll get the answer like this, right? Because dou f by dou x I vector, dou f by dou y j vector, dou f by dou z k vector. So there you will get dou f by dou x, dou f by dou y, dou f by dou z as a function of x, y, z. So output will be a vector point function for gradient that we already defined, right? We also given a note also. So we are taking a vector point function. For a vector point function, we are going to define divergence for vector point function, right? I've taken vector point function. So v is equal to f1i plus f2j plus f3k. This is the representation of vector point function where f1, f2, f3 are functions of x, y, z. Then the divergence of v, then the divergence of v written as del dot v, right? Del dot v. So del f means gradient, but here we have del dot v, right? Sorry, del dot v, or you can also write this as divergence of v, right? There we will use grade f, right? Grade f or del f. Here del dot v or divergence of v is defined as so del dot v, right? Del dot v. So delta is the this is gradient operator, right? So this is always dou by dou x of I vector, dou by dou y of j vector, dou by dou z of k vector, dot v, right? Dot v. So suppose if I have, instead of dot v, if I have f means we will have dou f by dou x gradient, right? But here we have dot v. This is nothing but this is the representation of delta, right? del operator. So dou by dou x of I vector, dou by of j vector, dou by dou z of k vector dot. Now we know what is b, right? So b is f1, because b is a vector point function. So this is f1 I vector, f2 j vector into f3 k vector. So to make a dot product here, so this will be dou f1 by dou x plus dou f2 by dou y, dou f3 by dou z, right? This is the formula for divergence of f, and you can infer that this is a scalar point function, right? So input is a vector point function, the output is a scalar point function, right? Because this will be here, there is no ijk here, right? There is no ijk here. So we will have some function of xyz as answer, right? Because f1 is a function of xyz, f2 is a function of xyz, so f3 is a function of xyz. Overall, we're going to have a function of xyz only. So if we give some input, output will be some scalar, right? So therefore, it should be noted that divergence of b, right? Divergence of b is a scalar quantity, right? It is a scalar quantity. Thus the divergence of a vector point function is a scalar point function, right? So very simple. So just remember this formula. So if you want to find the divergence of f, you just differentiate the ith component, right, with respect to x, jth component with respect to y, kth component with respect to z. That's it, right? Very simple. Okay. Now we'll move on to second definition. We're going to see 4 definitions now, right? So second definition is solenoidal vector, right? Solenoidal vector. So here input is a vector point function, right, for divergence. Suppose if this is equal to 0, right? Suppose if the divergence of a vector point function is equal to 0, then that vector is called solenoidal vector, right? Very, very important. A vector b is said to be solenoidal. A vector b is said to be solenoidal. If divergence of that vector is equal to 0, right, or delta f is equal to 0, right? Because you can always denote divergence of b as delta t or dab of b. If this answer is 0, then we say that b is solenoidal vector, right? Very, very important definition. A vector b is said to be solenoidal if divergence of b is equal to 0, right? So we'll move on to the second definition. So we're going to see 4 definitions. So this is 1, this is 2, now this is 3. Now we're going to define what is meant by curl of a vector point function, right? Curl of a vector point function. Curl of a vector point function. So we have defined already divergence of a vector point function, which is del dot p, right? Del dot p. So you have to make a dot product with the given vector point function with the delta operator, right? Delta operator is this. Okay. Now what we're going to do is, instead of making dot product, I'm going to make a cross product now. So that will be called as curl of a vector point function, right? So if you make a dot product with the delta operator, that will be divergence. If you make a cross product with this delta operator, that will be curl, right? Okay. So I'm going to write the same thing. So let b be any given. Let b be any given differentiable vector point function. That is b is equal to f1 I vector, f2 j vector, f3 k vector, where f1, f2, f3 are functions of x, y, z, right? Where f1, f2, f3 are functions of x, y, z respectively, then the curl of f, then the curl of okay, curl of b, right? You can also this is just a variable, right? Okay, so instead of b I'll write f, right? Because I already used b for divergence. Let us take f, right? So let f be any given differentiable vector point function, and let us take f to be f1I plus f2j plus f3k. Then the curl of f is written as del cross f, right? Del cross f, or you can also write this as curl of f, right? So curl of f or del of f uh, is defined as del cross f, right? Del cross f. So what is del? So it is differential operator dou by dou x of I vector, dou by dou y of j vector plus dou by dou z of k vector cross f, right? Cross f. So what is f? F is f1I. This is dou by dou x of I vector, dou by dou y of j vector, dou by dou z of k vector cross f1 I vector, f2 j vector, f3 k vector. So this is nothing but determinant of I vector, j vector, k vector. So del cross f, right? So what is del cross f? How you will make a cross product? Coefficient of ijk for del and coefficient of ijk for f, right? So that means del will be dou by dou x, dou by dou y, dou by dou z, right? Because delta is this, ith component is dou by dou x, jth component is dou by dou y, kth component is dou by dou z, and for f it is f1, f2, f3, right? This is the this is called curl of the given f. And again you can see this is a vector point function, right? So input is a vector point function, output is also a vector point function, right? Because when you expand this, you will have I times dou by dou x, dou by dou y f3 minus dou by dou z f2 minus j times you will have ijk here also, right? So therefore it should be noted that curl of is a vector quantity. So here note that the curl of the vector point function is again a vector point function. So very simple, right? So just remember the formula for del cross f and del dot f. So now we're going to introduce the fourth definition, which is irrotational vector. An irrotational vector. A vector v is said to be irrotational. A vector v is said to be irrotational if curl of f is 0. That's it. If curl of f is 0. If divergence of the vector is 0, then it is called solenoidal vector. If the curl of the vector is 0, then it is called irrotational vector, right? So these are very, very important 4 definitions. Now we're going to do some problems based on these, right? So just go through all the definitions. So what is how to find divergence? So you just differentiate the first component with respect to z, jth component with respect to y, kth component with respect to z, and if this is equal to 0, then it is called solenoidal. That vector v is called solenoidal vector. And you just find for if you want to find curl of f, you just put ijk delta operator dou by dou x, dou by dou y, dou by dou z, and this f component f1, f2, f3. Expand this, you will get a vector point function that is called curl. If this is equal to 0, then that v is called irrotational vector, or f is called, okay, you write f here because we are using f, right? A vector f is said to be irrotational if curl of f is 0, right? So we'll do some problems now. if f is equal to x square y I vector minus 2xz j vector plus 2yz k vector, find divergence of f, curl of f, curl of curl f. So we need to find these three things, right? Divergence of f, curl of f, curl of curl f. So here we have f to be equal to x square y I vector minus 2xz j vector plus 2yz k vector, right? So here what is f1, f2, f3? So here f1 is x square y and f2 is minus 2xz and f3 is 2yz, right? Because f is f1i plus f2j plus f3k. So f1i, f2j, f3k. So your coefficient of I will be those f1, this is f2, this is f3. So what is divergence of f? So it is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So differentiate this f1 with respect to x. So we'll be having 2xy. Now differentiate this f2 with respect to y. So there is no y term here. With respect, we differentiate f3 with respect to z. So we'll be having 2y, right? So 2xy plus 2y, or if we take this 2y common, so 2y into x plus 1 is the divergence of the given function. Very simple. You just differentiate this x, first component with respect to x, here with respect to y, here with respect to z, right? Now we will find curl of f. So curl of f is del cross f, right? So curl of f is del cross f. So this is nothing but I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So this will be I vector, j vector, k vector. So what? Okay, let's keep this as it is. Dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So f1 is x square y, f2 is minus 2xz, and f3 is 2yz. So you need to expand this. So this will be I vector into. So I'm doing this directly. So if you expand this column, this row will get cancelled. So this into this, right? So dou by dou y of 2yz. So dou by dou y will be 2z minus dou by dou z of minus 2xz. So this will be 1. So we'll be having minus 2x, right? So minus j vector into, now we expand this, dou by dou x of this will be 0 minus dou by dou z of this, again this will be 0 plus k vector into, so you just have to expand this into this. So this will this into this, right? So dou by dou x of this will be minus 2z minus dou by dou y of this. So this will be minus x square. So this is the curl of f. So which is 2x plus 2z I vector. So there is no j gap. So there is no j component plus k into minus x square minus 2z, right? So this is the curl of f. Is 2x plus 2z I vector plus k into x square plus 2z. Now we need to find curl of also, right? Okay, we will find curl of now. This is the curl of now. I will find curl of. So curl of will be, you need to find curl of. So what is curl of? We already find curl of, which is 2x plus 2z into I vector plus 0j vector minus x square minus 2z into k vector, right? So we need to find curl for this function. So this will be I vector, j vector, k vector dou by dou x, dou by dou y, dou by dou z. I just take this to be some f1, right? Just take this to be some f1. Curl of f1. Curl of f1 will be del cross f1. So f1 is curl f. So instead of writing here, you need to write f1 coefficients, which is curl f here, right? This will be 2x plus 2z 0 minus x square minus 2z, right? So expand this, you will find curl of curl f. Suppose if they ask curl f, that means you need to find curl for this vector point function again, right? So expand this, so this will be I vector into, so this into this, so dou by dou y it will be 0, right? Because there is no y component here, again it will be 0 minus j vector into, so this dou by dou x of this, so minus 2x dou by dou z of this will be 2 plus k vector into, so dou by dou x of this, dou by dou r will be 0. So we will have only j component here, right? So we will have only j component here. So if I take minus j, dou by dou x of this will be minus 2x, dou by dou is 2x plus 2x. Minus 2x is it? Yes. 2x. 2 is it? Yes, 2x. 2 is it plus 2x. Okay, so this will be so this will get vanished, this will get vanished. So if we take this minus outside, we'll be having 2x minus 2 j vector, right? This is the curl of curl f. Okay, here we have minus, right? Because this into this minus this into this. So 2x plus 2 j vector is the curl of curl f, right? So it's very simple problem. They have given f, they asked us to find the divergence curl f. So you just have to remember these 4 definitions and then you need to apply the result. That's it, right? So we'll move on to problem number 2. If f is equal to xy square I vector plus 2x square yz j vector minus 3yz square k vector, find divergence of f and curl f. What are the values at the point 1 comma minus 1 comma 1, right? So very simple problem. You need to find divergence and curl. After that we need to substitute this point and you need to tell the answer. Okay, so they have given f to be equal to xy square I vector plus 2x square yz j vector minus 3yz square k vector. So here our f1, so our f1 is xy square, f2 is 2x square yz, and f3 is minus 3yz square. So what about divergence of f? So it will be dou f1 by dou x plus dou f2 by dou y, dou f3 by dou z. So differentiate this with respect to x, so it will be y square with respect to y. This will be 2x square z with respect to z. So it will be 2z. So that means it will be 6yz, right? Now we need to find at the point 1 comma minus 1 comma 1. So this will be x, y, z. So y square is 1, 2 into x square into z minus 6 into y z. So 1 plus 2 plus 6. So 9 is the divergence of f, right? At this point. Now we will find curl of f. So curl of f is del cross f. This is nothing but I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. This will be I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So xy square, 2x square yz minus 3y z square. So differentiate this. So we'll be having I vector into, so dou by dou y of this. So this will be minus 3z square minus dou by dou z of this will be minus 2x square y. So minus j vector into dou by dou x of this is 0 minus so this again this will be 0 plus k into dou by dou x of this will be 2x. So we'll be having 4xyz minus dou by dou of this will be 2xy, right? This is the curl of f. So I into minus 3z square minus 2x square y plus k into 4xyz minus 2xy is the curl of f. Now we need to find the value at the point 1 comma minus 1 comma 1. So this will be I vector into minus 3 into 1 minus 2 into x square into y plus k into 4xyz minus 2 times x into y. So here we will have I vector into minus 3 plus 2 plus k vector into minus 4 plus 2. So minus I vector minus 2k vector, right? So minus I vector minus 2k vector is the value at that point, right? Minus I vector minus 2k vector. So we move on to third problem. So I think our problems are very easy, right? This is very important. So determine the constant a so that the vector b is equal to x plus 3y into I vector y minus 2z into j vector x plus az into k vector is solenoidal, right? So we need to find this a value. They are given that this vector is solenoidal, right? So we know that the vector is solenoidal if the divergence of the vector is 0. So for solenoidal, divergence of f is 0, or here we have b, so divergence of b is 0, right? Now what is b here? So b is this. So what is f1, f2, f3? So f1, f2, f3 is, so f1 is x plus 3y, f2 is y minus 2z, f3 is x plus az, right? Because b is f1i plus f2j plus f3k. So divergence of b is 0, right? So what is divergence of b? So dou f1 by dou x, dou f1 by dou y, dou f2 by dou y, dou f3 by dou z is equal to 0. What is minus 2? Okay, good. A is minus 2 is the answer. So dou f1 by dou x. So 1 with respect to x, right? So this will be 1. Dou f2 by dou y again, and this will be 1. With respect to z, this will be a is equal to 0. So that means 2 plus a is equal to 0. A is equal to minus 2. Right? It's a UPSC question. So A is equal to minus 2. So that means we need to find this value of A. So this is solenoidal. So therefore A is minus 2. Show that the vector. Show that the vector. There will be some problems based on this, right? You need to find the unknowns. If that is solenoidal, if that is irrotational, right? Okay. So determine. Show that the vector B is equal to sine y plus z I vector x cos y minus z j vector plus x minus y k vector is irrotational. So we need to show this vector is irrotational. For that we need to show curl of f is 0, right? So what we need to show is curl of v, right? That is del cross v is 0. This is what we need to show, right? So we know that the vector is irrotational if curl of that vector is 0, right? So you can see the vector is irrotational if curl of f is 0. The vector is solenoidal if divergence of that vector is 0. So curl of v is 0. Okay. So what is f1 here? So f1 here is sin y plus z. F2 is x cos y minus z. F3 is x minus y. So we will find del cross v. So I, j, k, dou by dou x, dou by dou y, dou by dou z. And this will be sin y plus z, x cos y minus z, x minus y. So this will be I vector into, now with respect to y, this will be minus 1. With respect to z, this will be 0. This will be minus 1 again. Minus j vector into dou by dou x of this will be 1. Minus dou by dou x of this will be 1 again. Plus k vector into dou by dou x of this. So this will be cos y minus z. Right, because derivative of x is 1, cos y is constant. Sorry, cos y, right? Cos y. And with respect to dou by dou x of this is cos y. Dou by dou y of this will be derivative of sin y is cos y. So in between we have minus. Right, so you can see this is 0i, 0j, 0k, which is 0. So this implies del cross v is 0. That means v is irrotational. Right, v is irrotational. Fourth problem. Fifth problem. If b is equal to e power xyz I vector plus j vector plus k vector, find curl b. Right, so this is nothing but e power xyz I vector, e power xyz j vector, e power xyz k vector. This is f1 I vector, f2 j vector, f3 k vector. So f1, f2, f3 all are e power xyz here. So we need to find a del cross v, this curl of v. So this is I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. So b, so this will be e power xyz, e power xyz, e power xyz, right? So this will be I vector into, so dou by of e power xyz. So e power xyz with respect to y, so this will be 1 into xz minus dou by z of this. So e power xyz with respect to z will be having xy, right? So minus j vector into dou by x of this. So e power xyz with respect to x, yz minus dou by z of this. with respect to z means we'll be having xy plus k into dou by dou x of this. So e power xyz with respect to x means we'll be having yz minus dou by dou y. So e power xyz into xz, right? So you know derivative of e power something, right? So dou by dou x of e power f of x is e power f of x into f dash of x, right? So this is I think we can this is an answer, right? That's it. So e power xy, if I take e power xyz common, if I take e power xyz common, xz minus xy into I vector. What I'm doing is I'm just taking this as plus e power xyz. I'm just rearranging these two terms, xy minus yz into j vector, right? So I'm just interchanging this term and then I'm multiplying minus minus will be plus plus e power xyz yz minus xz a vector, right? This is the curl of the given vector. Sixth problem. Find the constants. Find the constants a, b, c so that the vector is irrotational. The given f to be equal to x plus 2y plus az I vector bx minus 3y minus z into j vector 4x plus cy plus 2z into a vector, right? So we need to show, we need to find the constants a, b, c so that the vector is irrotational, right? So for irrotational, del cross f is 0, right? Del cross f is 0. So I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z of. Now what is f1, f2, f3? X plus 2y plus az, bx minus 3y minus z, 4x plus c5 plus 2z, right? This is equal to 0. Now expand this. So this will be I into, so dou by dou y of this. So this will be 0 plus c plus 0 minus dou by dou z of this. So 0 plus 0 minus 1 minus j vector into dou by dou x of this. This will be 4 minus dou by dou z of this. So 0, 0, a plus k vector into dou by dou x of this. So this will be b, right? This will be b minus dou by dou y of this will be 2 is equal to 0. So this will be I vector into c minus minus. So c plus 1. I'll write plus j vector into a minus 4, right? I'm just interchanging this. Plus k vector into b minus 2 is equal to 0. So 0 means it is 0i plus 0j plus 0k, because we know that the output is a vector point function. So 0 vector is 0i plus 0j plus 0k. So just equate this. So c plus 1 is 0, a minus 4 is 0, b minus 2 is 0. So a is 4, b is 2, c is minus 1. Right, so this is the value of a, b, c. So I'm just equating a coefficient of x, y, z. Sorry, equation of ijk. Right, so c is minus 1, a is 4, b is 2. if R vector is equal to xi plus yj plus za, prove that divergence of R vector is 3, curl of R vector is 0. Right? It's very simple. So they are given R vector to be xi plus yj plus zk. We need to prove divergence of that vector is 0, curl of that vector, sorry, divergence of the vector is 3, curl is 0. So we have f1 to be x, f2 to be y, f3 is z, right? Because f1i plus f2j plus f3k. Now we will find the divergence of R vector. So it is dou f1 by dou x, dou f2 by dou y, dou f3 by dou z. So with respect to x, with respect to y, with respect to z. So this will be 3. And what about curl of R vector? Curl of R vector is del cross R vector. So it is I vector, j vector, k vector. Dou by dou x, dou by dou y, dou by dou z. This will be x, y, z. So I into, so dou by dou y of this is 0. Dou by dou y of this is 0. Dou by dou x, dou by dou z again 0. Dou by dou x of this is 0. Dou by dou y of this is 0 again. So therefore this is 0. Right? So therefore if R is xi plus yj plus zk, divergence of that R is 0, curl of f is 0. That's it, right? So these are I made all problems based on definition and curl. So we're going to start. We're going to prove some vector identities in next class, right? So we'll start fresh in next class. In next class, what we're going to do is we're going to solve vector identities, right? So actually there are how many identities there? So 9. Yes. So actually there are 11 vector entities, right? Very important. So this R vector is a vector point function, right? Whenever you have ijk, that is vector point function. So there are 11 identities, right? Identity means based on divergence, curl, and gradient, we will be seeing some results based on combining all these three. For example, curl of grade f, curl dot divergence of f is something. So combining all this, we're going to have 11 vector identities, right? All are very important. So all are UPSC questions, right? So there are only 11 entities, right? So you have to study those 11 entities that we will start in the next class, right? So after finishing 11 entities, so we'll do some problems and some more problems, and then we will wind up this first topic, right? So next class we're going to start vector identities, right? Vector entities. There are 11 entities that we will prove in the upcoming classes, right? So if you have any doubt in this class, you can ask. We'll wind up today's class. So this is a short class. So I need to complete this topic so that I have completed. The next class we will start freshly, right? Is there any doubt? Okay, so no doubt, right? Okay, thank you. Next class we will start vector entities, right? Thank you.